Good evening, everyone. Again, there is delayed in uploading the next video, but as I had promised to you, the next class will be of the vector, and therefore today we are going to take a lecture on mathematics for physics, or we may call it mathematical physics. In this course, we may include the first few chapters of the physics of class 11, unit and dimension, vector, and kinematics. Let us start now. Mathematics for physics, or mathematical physics. In this course of physics, firstly, we want to know what is mathematics. Here, the genuine question is that what is mathematics? Before indulging in that, what is mathematics? Firstly, we want to know subtle difference among a hypothesis, postulate, law, and definition. And then we are going to distinguish between these things. You may call it definition, postulate, hypothesis, law. We are going to take these things at one side, and the another side is explanation. So let us see how we are going to distinguish one side of a things to the explanation. Firstly, we are going to take here subtle difference between these things: hypothesis, postulate, law, and definition. Look at now. So firstly, hypothesis. It is a theory which can after testing be accepted. To clarify the definition of hypothesis or the hypothesis, recall that what Amedeo Avogadro said: at same temperature and pressure, equal volume of all the gases contains equal number of molecules. equal number of molecules. This was hypothesis. Later on, we have been tested by taking different gases, and we found that yes, this hypothesis is true. So in this way, we are now acquainted, we are now well known about hypothesis. Now the next one, as we are going to discuss this briefly here. Okay, so next one is postulate. It is something that is assumed to be true. When we encounter postulate, then we are not going to investigate whether this statement is right or wrong, whether something has been provided in the postulate which is right or wrong. We are not going to investigate it. Like, look at here. Suppose this is a line, and at one point on the line there is a ray. So obviously we are looking, two angle has been formed, say alpha and a beta, and we all know alpha plus beta is equal to 180 degree. Why? Why it is 180 degree? Why not 360 degree? Why not 90 degree or any other degrees? This is in Euclidean geometry, and we start without proving it whether it is 180 degree or not. So we all know it is known as axiom. So the postulate is as good as axiom. Okay. We also know that Bohr's postulate, Niels Bohr, about an atom, how electron, proton and neutrons are inside the nucleus. As per Bohr, in fact Niels Bohr, electron revolves around the nucleus in certain energetic path. That's the postulate. We are not going to investigate it because it is the postulate given by the Bohrs. And path is circular as per Bohr's postulate. And the vital postulate is given by Bohr's is angular momentum of an electron in any particular orbit is constant, conserved, fixed. So as per Bohr's, ME Vn Rn is equal to n multiply h over 2 pi. However, it is also Dirac constant h cross. So here mass of the electron, speed in the nth orbit, radius of nth orbit in which electron revolves around the nucleus. N is the orbit number. Later on, as per Schrodinger, it is well known that it is the principal quantum number. However, altogether different issue. I am not going to indulge on that more here right now. Just we are going to understand what is postulate. That is why we can find here. So this is the postulate. No one can prove it like that here. alpha plus beta is equal to 180 degree. No one can prove it. We have to proceed from here. So it is the birth of the quantum mechanics. This is the Bohr's postulate. As per this, whole of the quantum mechanics is based on. That is why postulate. It means that is assumed to be true. Okay. Now, the next one. Next one is law. A universal statement about the operation of nature based on empirical observation of the physical behavior tested by scientific method or tested using scientific method. Better to write using. Tested using scientific method. This is law. Look at here. It is a universal statement given by some giant like Newton, Albert Einstein, Isaac Newton, in fact, Niels Bohr, too many scientists. Universal statement about the operation of nature based on empirical observation of the physical behavior tested using scientific method. For example, Newton's second law of motion, net force acting on an object is rate of change of linear momentum. If one particle, momenta in case of system of particle comprises more than one particle. So this is like that. It turns out to be as per Newtonian mechanics, mass times acceleration. However, we will see later on, this is the mass. However, mass is mass, I have told you in the earlier lecture, but this mass is modified or mathematically constructed if the speed of the particle is comparable to the speed of light. So at that moment, this law is not as mass times acceleration. So this has been modified. However, one cannot write that m naught rest mass over under root 1 minus v square by c square, not so. Other term also comes into picture in case of Newton's second law. So well modified when the speed is approaches. We will see in the classes when we deal magnetic field. Before that, we will take off relativity classes. So that will be very clear at that moment. But right now, take patience. So here, this is a law, mass times acceleration. If one can say no, mass square times acceleration or mass time vector A dot vector A. No. If we are intended to write mass square times acceleration or mass times acceleration square, you may write. No problem at all. But you have to prove it first. And the world scientist will going to observe your finding. And then that will be universal. Till we all have to follow this mass times acceleration because it is a law. It is abstract of the nature. It's a law. One cannot touch it. One cannot see it, but one can experience it. So that is why it is a law. Here, the word comes into picture, empirical. What does it mean? The idea based on observation or experience. Which is not proved as a theory or by a pure logic. Means it is totally based on observation or experiences, not by any theory or by any pure logic. So that's the empirical results as we know. So this is the law. Look at the differences between these things, hypothesis, postulate and law. Finally, we are going to take definition. It is a statement. It is a statement of the meaning of a term. Of the meaning of a term. Of a term. Of a term. Nice. What is term? If you know the concept of term, then we are going to understand in the first chapter of the physics, unit and dimension, the principle of homogeneity. What is the principle of homogeneity? In a particular relation, every one of the term must have same unit and dimension. Every one of the term. So there is a term. Then what is term? We will see later on. Right now, little later, what is term. But the definition are of 3 kinds. First, intentional definition. Intentional definition. Intentional definition. That is, which try to give sense of a term. Sense of a term. Second is extensional. Extensional definition. That is which try to give objects, which try to give the objects that a term describes. And the third one is ostensive extensive definition. That is, which carry the meaning of the term by pointing out examples. These are, however, brief discussion about these things, because these things we may encounter in whole physics courses, whatever in the higher secondary physics or undergraduate physics, and might have been master degree physics. So we all encounter these things. So that is why I tried myself to give you the same looking terms, but they have subtle differences, what I have shown for you. Okay. Now, just these things on one side, and the one thing is the another side is the explanation. Explanation. If we are discussing, say, about hypothesis, law, definition, postulate, we may describe it the way we like most. So, when we are describing the things, what is our motto? To describe it positively. But sometimes, during the discussion, during the explaining the things, may be wrong. Then what we conclude? If we explaining the things, then most probably we are explaining correctly, but sometimes we may describe it wrongly. However, seldom these things happen. Frequently we or always we describing something by taking its positive view, or positively or correctly. So then we call it its explanation. Its explanation. Why we are stressing too much on these things? Because if one can ask you, what is mathematics, what is physics, what is chemistry, what is the any subject, whatever, what is the fan, what is the table, what is the room, what is the universe, what is the nature, what is moon, what is sun, etc. So now you are in a position to speak anything. Then it might be hypothesis, postulate, law, or definition. If not, then it may be explanation. So right now we have learned that explanation of something may be right, most probably, but it may be wrong. So without any hesitation, now you are in a position to speak anything about anything. That is why I have described these things somehow in length. However, it is briefly. We describe it briefly. Okay, so now just we are going to know here what is mathematics. The very obvious questions, too many answers is that dealing of number, useful in physics, useful in chemistry, useful to anything else. Is it definition? Or is it law? Is it hypothesis? Is it postulate? Or it is its explanation, that is the explanation of mathematics. It might have been anything. So exactly we are going to understand these things, because if we are saying it is a hypothesis, then or law or postulate or definition, we have to provide some specific words as given by the giant. Say Isaac Newton, Albert Einstein, Dirac, like that. So we have to follow that. We don't write anything apart from what they have been provided. So concrete words, a specific words for a particular aspect. Then it may fall under the category hypothesis, postulate, law and definition. If not, then it is explanation. So that is why just I have providing you strength to speak anything about anything. Okay. So what is mathematics? So answer is here. It is mother of all the languages. All the languages. Mother of all the languages. It has certain pattern and a structure. Certain pattern and a structure. Certain pattern and structure. It may be understood by number 1, expression. Number 2, identity. Number 3, equation. Number 4, inequality. And number 5, inequation. If we are able to understand these 5 terms here, expression, identity, equation, inequality and an equation, we are in a position to understand what is mathematics. Look at here, 5 things. This number 5 is very nice number. So as we know, 5 years planning. Panchtantra is a book written by Vishnu Sharma. And now Prophet Muhammad Sahib also provided 5 things. Namaz, Roza, Zakat, Hajj, 5 things. The 5 number is very magical number in fact. So here also 5 things. Look at here, expression, identity, equation, inequality, equation. Fund of 5 is very nice. 5 years planning in my country, India. So this 5 is very nice things. So 5 things: expression, identity, equation, inequality and inequation. So we will learn these things one by one. However, in a length, not too much, but in a length. Firstly, its definition is mother, pattern and structure. So definition, we call it definition. The definition of mathematics includes 3 major words: mother, pattern and structure. So just we are going to explaining it, that is explanation. So I have told you earlier, we have to say something. All the times we are trying it to be positive, but sometimes maybe negative. So now I am this time going to describe it positively. Look at. So here mother. Why we call it mother? As we know, Galileo, what he has written? God has created the universe by the knowledge of mathematics. Do you think over it? Galileo, giant. What he said? God has created the universe by the knowledge of mathematics. And what we are going to study here in physics. Later on I will show you what is the definition of physics. So its first line is that thinking of natural phenomena. So what we are going to think, what we are going to study in physics? Natural phenomena. And this nature is made by the God, Ishwar, Allah Pak, by the knowledge of mathematics as per Galilean Galileo. Do you think over it? So firstly, we want to know mathematics. Then we are going to understand physics. However, someone may explain that this is the concept, this is the mathematics. So mathematics is the part, not as much. Yes, thinking, firstly thinking. Thinking is physics. And we convert this thinking by doing the subtle and accurate experiment in the laboratory and converting this finding in terms of this simpler mathematical relation by means of these things here. This is the mathematics thing. That is why mathematics is the language of physics. Language of physics. Okay. So we have to go into depth of the mathematics. We are as deep as in the mathematics, we are as good in the physics. However, physics has two parts, thinking, imagination, altogether different issue. But these things, thinking, these imagination, we have to convert into a simple mathematical relation by means of these things. That is why. Look at here, mother. Just I am going to an example. Look at here. So we all know APPLE, apple. It's a kind of edible fruit which give you a lot of energy, delicious as well. But if you write here the same letters PPLE, A. So we are going to search this word in a dictionary, whatever college dictionary, Oxford or Advanced Learning Dictionary, maybe any dictionary, universal dictionary, maybe. We are not going to find this word. But this word is frequently in any dictionary, whatever it may be. It means the word has been permuted in a such a way that this word give you meaning. Also has got some meaning, but yet no, not understood. So if you write what is called dictionary, then we have to use the permutation and combination. What is this? Mathematics. So even in writing of the dictionary, we require mathematics. Look at here. So second example is that the capital A. So we write a little bit slant and almost 30-degree angle here. We divide the slant height in 3 equal parts and the horizontal line from the bottom at the 1/3. This is capital A. So mathematics is involved when we try to write capital A. Look at here, the language English, capital A. We write a digit, then we have to move the hand in this way or that way, geometrically. So this is the mathematics. So that is why it is mother of all the languages. Okay. So here the pattern, second is pattern. Just look at what is pattern. So we write here 2, 4, 6, 8. Anyone can guess that the next number will be 10. Why? 12. Why? Because each number is 2 more than the previous one. That is why we are able to speak what is the next number. Look at the here. So 1, say 1/4, say -10. What I am going to write here? One cannot guess. But Allah Pak, what He made us able to understand. And then I is the only person to know what I'm going to write. No machine will going to say, put in my brain or put my in heart. No one going to say, because what I'm going to write till date. Later on, I'm not very sure what is going to happen in the future. But we do say here, so no one is able to speak apart from me and then Allah Pak, what I'm going to write here, the next number. So this is also a dealing of number, this is also a dealing of a number. So this is mathematics and this is not a mathematics, this is arithmetics. This is mathematics, yes, because it has got pattern. However, both are the dealing of numbers. If one can say mathematics is dealing of numbers, so it is the explanation, not the definition, because not all such dealing is mathematics. Because head goes pattern. Okay, the pattern is very nice to understand. So if you try to understand the Mughal dynasty, the first king, the Akbar, and then so on, if the first and the middle and the last, and we are going to understand the Mughal dynasty, so no way are going to understand that. Next one is that a smallest unit of the living things. So we all say that the cell. Now it is the living smallest unit. Organelle, mitochondria, Golgi apparatus, too many things make a cell. A group of cell, tissue. Group of tissue, organ. Group of organ, organ system. So if you want to know you have to know from organelle. That the pattern. We change the pattern, so we are not going to understand quite easily. First we are going to do the organ system and then the organelle and then the organ. So no way we are going to understand. So we had to study in a certain pattern. In my study, pattern wise my study, then we are going to understand quite easily. That is why I am saying that the pattern. What is pattern? Now we are going to understand what is the structure. Look at here. What is structure? So to understand the structure, look at here. Structure. Look at 1 plus 2 plus 3 dot dot plus n. This is equal to n plus 1 over 2. So you know. If you are not knowing, then let us consider. We know this happens too. If we know the things, let us consider that. If you are knowing, then okay. If you are not knowing, then assume you are knowing these things. Here, 1 plus 2 plus 3 plus dot 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 plus n is equal to n into n plus 1 over 2. Then I am going to ask you, find the sum of this 5 plus 10 plus 15 up to n terms. Still, term is to be discussed. Just I am going to discuss after this. So if I am asking you to that, find the value of this, and you are saying no sir, I am not able to that, it means you are not. Grab it nicely. So I am going to show you this again and again till you are not able to solve this one. Why I am saying like that? Look at here. If we take it 5 common, the result will be 1 plus 2 plus 3 plus n. So this is known. N into n plus 1 by 2. So this is 5 n plus 1 over 2. And this is your answer. If one can say, no sir, I am not going to take common. So no way, you are in class 11. Because to take common, multiply, division, LCM, SCF, etc., we have learned these things in school, lower school mathematics, not higher. Higher is the level, class 11 and 12. That is why. So, these are the things. Now, I am going to prove it. Why 1 plus 2 plus 3 plus dot 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 plus n is equal to n into n plus 1. However, it is quite easy by arithmetic progression. So, you are able to find its value. Okay, no doubt in it. But I am going to give you just another proof. How interesting. Because look at here, is the 1, 1, 1 and so on 1 here. However, If you're writing 2, so customary we are not writing 2 to the power 1. If you're writing 5, 5 to the 1, 10, 10 to the 1, no. Understood. But just I'm showing here, for interest, I am going to prove it. So here is the one, to take the identity here. Say k plus 1 whole square minus k square is equal to. So is the 1, take 2. So a plus b whole square, a square plus b square plus twice a into b. So k square has to be cancelled here. So left out here twice k plus 1. In succession, take k is equal to 1. So put it here. Become 2 square minus 1 square twice into 1 plus 1. So take k is equal to 2 here. 3 square minus 2 square, 2 into 2 plus 1. Take it here, k is equal to 3. This is the 4 square minus 3 square. So 2 into 3 plus 1 and so on and so forth. Take k is equal to n. Put it here. N plus 1 whole square minus n square is equal to twice n plus 1. Now add it all together. Look at here, plus 2 square minus 2 square cancel, plus 3 square minus 3 cancel, and so on. This will cancel somewhere here, and 3 n square somewhere here, like that. What are left? Second term and second last. Write it down. Look at the cutting style. So not like cutting, no. Because now it is, anyone can say that yes, 2 square is cancelled by 2 square and 3 square. Look at the geometry of the cutting. This is known as art of calculation. You must know if you are calculating like that. That is very clear. Okay, not like in the same geometry, not like so. Keep in mind. So here, n plus 1 whole square minus 1 square give you, take 2 common from here. So this becomes 1 plus 2 plus 3 dot dot plus n. So here 1 plus 1, 2. 1 plus 1 plus 1, 3. 1 plus 1 plus 1 plus 4. It means 1 plus 1 plus up to n terms, they give you n. So this is the n. Now do it simplification. That gives you the result. So here, so this is the a square, b square means n square plus 1 square twice a into b means twice n into 1. So 1 square has been cancelled out here. What is left here? N square plus twice n. 1 square has been cancelled out. Here twice. So we have to find the value of this. So take it as a capital S. This is n. So from here we all are able to understand quite easily. So it comes out to be n into n plus 1 by 2. Now it has been proved. Okay. So this is the proof. However, by applying the arithmetic progress formula in one line, sum of the arithmetic progression is n by 2 bracket twice a is the first term plus n minus 1 into d where d is the common difference and is the number of terms. So quite easily the cell will be proved. But now we are taking the another approach known as identity approach. Now next is that 1 square, 2 square, 3 square, n square is equal to n plus 1, 2n plus 1 over 6. Why we are showing these results in the course of physics? Because the heading is mathematical physics or mathematics for physics. So in case of calculating moment of inertia, center of mass, might have been electric field, magnetic field, gravitational field. So we have such series we may encounter. So if we know the things, just we are going to use the result. That is why things. Just we are going to prove it. Look at here, 2 is everywhere. Inevitably, we have to write 2 because if we write 2 to the power 2 is equal to 2, then no way to understand 4 is equal to 2. That is why we have to show. But in case of power 1, You may write or not, then okay. So now what we have to do here? So we have to take, like here, just we have to remove 2 here, 3 here. Now we have to weight what is on the right hand side, to weight it here. We have to find it and then put there. So a plus b whole cube, as we all know, a cubed plus b cubed thrice a square b plus thrice a b square. So use the result there. This is k cubed 1 cubed thrice k square 1 thrice k1 square minus k cubed. K cube has been cancelled out here. So what is left? The left things we have to write on the right hand side. So here it is 3k square thrice k plus 1. Again on the same approach like that, put k is equal to 1. We'll get here 2 cube minus 1 cubed is equal to thrice 1 square thrice 1 plus 1 here. So put here k is equal to 2. The 3 cubed, 2 cubed is equal to thrice 2 square, 3 into 2 plus 1. Put here k is equal to 3. The 4 cubed minus 3 cubed thrice 3 cubed thrice 3 plus 1. So on and so forth. K is equal to n. Put it here. N plus 1 whole cubed, n cubed thrice n square thrice n plus 1. Now again, in a similar manner, so here it's cancel out, this cancel out somewhere here and some here n cube. So what is left? Second and second last. So here n plus 1 cubed minus 1 cubed is equal to thrice 1 square, 2 square, 3 square, order to n square. So here n as before. So now we have to find the value of this. Take it as capital S. Now one thing has been left here. So firstly we have to write here 3, 1 plus 2 plus 3 dot dot plus n and then n. So we have to find S. So here look at a cube, n cube, b cube, 1 cube, thrice a square b, thrice n square into 1, thrice ab square, thrice n into 1 square. So 1 cube has been cancelled here. What is left? I am going to write here left things. Here the n cubed thrice n square into 1 thrice n 1 square. 1 cube has been cancelled out here from here. This is thrice, say take it S because we have to find the value of this. And now plus 3 n plus 1 plus we have to find S here. This implies S is equal to what? Look at here. So n cube thrice n square thrice n minus 3 over 2 n into n plus 1 plus n and whole divided by the twice here the thrice divided by 3. So whole divided by 3. Now I am going to provide you one trick here. Then going to simplify such things is that multiply the whole things or take common the LCM of the denominator, the trick of the calculation, LCM of the denominator. What are the denominator here? 2, 1, 1, 1 and 1. What the LCM of 1, 1, 1, 2, 1? The LCM is 2. And then take out 2 common. I am saying like that because something here 3, 5, 2, 10, etc. If the denominator is there, such like denominator like that, then firstly we find the LCM, take the LCM common. If we taking the LCM common, so denominator has been disappeared and everything comes in denominator. So that is why. So to take it to common here, this becomes 1 by 6. Doing that, so it becomes twice n cube, 6n square, 6n minus 3n, n plus 1 plus twice n. So after simplification here 1 by 6, then what is here? Twice n cube, yes, okay. 6n square, there is n square, yes, here is 3n square. So this is the thrice n square. 6n here minus 3n, 6 to 8n minus 3n plus 5n. Okay, yes, correct. So what is here? 1 over 6. So take n common. What is left here? Twice n square plus thrice n plus 5. And shortcut method of factorization is that. Here is the, take the 2 factor like that. The twice n, n. We have to take here the plus sign. It came through plus plus or minus minus. If we provide minus minus, no way to come here plus. We have to put here plus plus. Look at the calculation. Look at the calculation. A plus b cube minus thrice like that, thrice into 1 plus 2 plus 3 plus n, okay, right? So here 1 cube is cancelled out, so n cube, n square, thrice n, that's fine. Thrice is thrice into that, okay, plus n, that's nice. First time what I did here, so take that, divided by 3, it's okay. N cube, thrice n square plus thrice n minus 3 by 2, n into n plus 1. Yeah, here is the mistake. Look at here. The plus n, that side becomes a minus n. So that was the mistake here. So minus n. So it becomes here minus 2n. So now look at here. 3n, okay. Minus 2n minus 5n plus n. So not there 5, only the n. Only the n. N. So n has been common, comes out to be here 1. That was the mistake. Okay. Why I am able to pick up the mistake? Because I did the mistake here minus sign, because we have to prove the result. Otherwise, that may be wrong. So n into n plus 1 into 2n plus 1. I am not getting here. I am not hiding my mistake here. Yes, I am showing in front of you. That's the honesty. Everywhere, anywhere, we have to show. Okay? So that is why. Now, we have to put 1, 1 here. So after multiplying, we are going to get quite easily that. So this is the result and has been proved. Okay? Look at here now. If we have to prove 1 cubed plus 2 cubed plus 3 cubed, like here, 1 cubed, 2 cubed, 3 cubed, plus dot 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 plus n cubed, comes out to be n plus 1 over 2 whole square. So you are able to show that. We have to put here 4. We have to use this identity. And now left right side, and you have to calculate firstly and then put here. So power 4, power 5, power, why not power n? So we have to use the binomial theorem for positive integral index. However, we have also binomial theorem of any index. So we may apply here any index because positive integral index, in case of any index, so we may apply the formula of any index, but in case of any index, 1 plus x, where x should be, mod x should be less than 1. So that is the criteria. So that is why positive integral index, no any criteria on positive integral index. So we may explain like that, or we may use k plus 1 whole square into k plus 1 whole square. Separately multiply and then multiply, you get that and subtract that, and you will get the right side. And proceed, you are able to prove that. If you are not able to prove that, then comment on the comment box. I will show in the next class, surely. So here, so up to the 3 powers, not the 4 or 5 powers, we are able to do that by using the binomial theorem of positive integral index. That's okay, fine. But in higher secondary physics courses, so seldom or rarely we may find power 4 or 5, up to power 3, that's okay. That's okay. So that is why up to 3 powers we have to memorize these results. So that will be helpful in the subsequent physics chapter. Okay. Now just I have promised to you what is called term. Term. What is term? The answer is the concept of term arises in case of algebraic addition. Algebraic addition. Algebraic addition. Algebraic addition. What is algebraic addition? What do we mean about algebraic addition? So we may say that subtract 2 from 3. So we write like this. One may say same thing, add -2 in 3. Result will be same one. That is why this is the way it's called algebraic addition. So after multiplication of plus with the minus give you minus, the same things. That is why algebraic things. So if things is something plus something, or too many things are separated by plus or minus sign, then counted as a term. Look at here. A plus B, take this 2 term. Here A plus minus B plus C, 3 terms. Here A into B taken as 1 term. Here A into B into C taken as 1 term. So here again A, B, C over D, E, F. However, D, F not equal to 0. So then okay, otherwise not defined. So it's taken as 1 term. The term is here. And we have to find the coefficient. Frequently here, coefficient of unit vector I is the x component. However, component means is also a ambiguity is there. Someone treating component is a vector. Component of vector is a vector, okay, that's nice. But sometimes we taken as a scalar component or vector component. That's for distinguish vector and a scalar. However, Ax is not a scalar, but too many books Ax, Rx taken as a scalar. A scalar is only when in the rotatory transformation the value remains same, then it is a scalar. Maybe positive or negative, no matters at all. But in rotation, Ax, Rx, Bx, the x component, Ry, y component, etc. has got changed in rotation or transformation. So that is why it is not a scalar. A scalar will not change in rotation or in any transformation. That is why we will show in very detail in the vector. These are under the mathematics or mathematical physics. That's fine. So here, so now here the case like that. So algebraic term. So coefficient, just I am going to here conclude the class here after knowing what is coefficient. 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 Coefficient always with respect to a term. With respect to a term. Okay, with respect to a term. Here I get twice x square y share 5x plus 7, that has got 3 terms, is the first term. Coefficient of y, coefficient of y, leaving y all factors. Look at here, I am calling about factors. I am calling about factors. So first factor, second factor and third factor. We are taking here first, if we are taking counting from here, the first, second, third, it all depends upon the frame in which you are working. So it's 2x square. Coefficient of x square 2y. Coefficient of x square y is 2. So this is known as numeral coefficient. Numeral coefficient. The coefficient of twice x square is equal to y. So a variable or conjugation with the or multiplication with the numeral are known as literal coefficient. Literal coefficient. Literal coefficient. This is also literal coefficient. Y is also known as literal coefficient. Literal coefficients. They are very vital when we consider the x component, y component, z component, coefficient of k, z component, coefficient of j, y component, coefficient of unit vector I, that the x component, etc. So that will be very fruitful when we are taking the mathematical physics like vector, kinematics, etc. So here just we are going to confine our lecture here. Next day we proceed from here. Okay, thank you.